All right, guys. All right. Welcome to Frank Teaches MLOps. Yeah, guys. Yeah, my lovely viewers. My lovely viewers. Yes. Yes, guys. So today I will be talking about how to deploy machine learning model with KServe. You get me right? With KServe to production. The KServe is Kubeflow Serve, right? So this service or this tool, the KServe tool, runs on Kubernetes, and it is used to serve your model, right? It's used to create inference, right? To serve your models. So I did a video sometime, all right? This is a video, guys. Deploy machine learning models with KServe on Kubernetes. First approach. All right, so this is just to on the documentation, all right, from Kubeflow, all right. They have hurriedly, or something I would say, a quick start, right, on how to understand, a quick start on understanding how to deploy KServe for the first time. All right, so I name it, I describe it as first approach because it's very basic, right? Very basic, and they have model hosted on Google storage, right? Which you just need to deploy the model directly into your Kubernetes cluster. All right. So, however, that approach is very basic, very basic, very elementary, and that is what I demonstrated in this video. All right, in this video. Now I'm taking things seriously now. All right, I'm taking things a step further in the sense that I'm doing production with this new video, right? Right, this new video is deploy ML model with KServe to production. So in here I have used my own model, the model that I built and stored on my AWS S3. All right, I'll be deploying that model, but in this video I deployed Kubeflow or Google's own model. All right, Google's own model. So guys, you need to watch this first approach first. If you're a beginner in KServe, you need to watch the first approach so that it will give you an insight of what I'll be discussing in this video. All right, that's one. Then two, because there's going to be a lot of moving parts. All right, there's going to be a lot of moving parts because I'll be deploying directly from Jenkins. All right, from Jenkins to Kubernetes. All right, I will explain this structure, guys, from Jenkins to Kubernetes. All right, so you need to understand how I have integrated Jenkins with Kubernetes. Okay, and then other basic things I did. All right, beneath the hood. However, is something that I will still have to do in this video. So you also need to watch continuous deployment with Jenkins and Kubernetes. So this is DevOps level, continuous deployment with Jenkins and Kubernetes, right? So you just need to have a grasp of these two videos to understand my perspective, right? So guys, let's get started. Okay, so this is my architectural workflow. Yes, this guys. So in my architecture, I have about 1, 2, 3, 4, 5, 6. I'm using 6 tools: Github, Jenkins, KServe, Kubernetes, MLflow, and AWS S3. All right. Now this is the flow. I have my GitHub. On my GitHub, I have my files. I have my Jenkins files. I have my input.json. I have my inference service.yaml. Like I said, you will get to understand inference service.yaml when you watch this video, because I won't be explaining what an inference service is anymore on this new video. All of that was explained in this video. So you need to go and watch this video, guys. All right, you need to watch it. And please, guys, help us and subscribe to our channel, please, because you'll be getting MLOps content back to back to back. All right, great. Then we have the model.py, right? Then secret.yaml, service accounts.yaml. So there are a lot of things in those files which I'm going to walk us through. Now on the Jenkins side, I'll create a Jenkins pipeline. All right. Now this is just when Jenkins pulls the code, when Jenkins makes a request to GitHub to have this code, and GitHub will respond. That's just the flow. Request, response, request, response. All right. Just continuous integration and continuous delivery. All right. I'm just demonstrating here. All right. Great. Then in this process, Jenkins is going to deploy some experiments to an MLflow endpoint. All right. Some experiments to MLflow, and in turn, that experiment will trigger and create a model that will eventually get uploaded to your what? To your AWS S3. All right. Great. And still on Jenkins, all right, Jenkins will use this file, the inference file, to deploy the model, this model that is here, to deploy this model into your what? Kubernetes cluster. All right. Then somewhere here is me. This is my control machine. So on this machine, I've installed AWS CLI, I've installed kubectl, then I've downloaded my kubeconfig file, and I'll start operating my cluster. So let's talk about this guy briefly because it's very short. So on here, I have my guy here. So that's a control machine. So I've installed AWS CLI. I have AWS CLI already. Okay. I also have kubectl dash version already. Sorry, there's not that dash, please. All right. Then I have my cluster already. kubectl gets node. I've already integrated. All right. So I have my cluster. So my cluster is running as EKS. EKS, guys. So here's my cluster. Okay. Here's my cluster, and my cluster have 2 worker nodes. Okay. I have what? 2 worker nodes. So this is my cluster and runs 2 worker nodes. Right. So you can see I can talk to my cluster. Right. So if you have not watched my continuous deployment with Jenkins and Kubernetes, please guys, watch it before coming to this video. All right, great. So this guy is now sorted. Great. Good, guys. Now, let me now start. I need to install KServe. But before I do that, let me go to explain these files on my GitHub repo. So let's come to the GitHub repo. So this is my GitHub repo. All right. So in here, I have the inference service, I have the model of PY, and I have secret.yaml and service accounts. So let's start with Jenkins file. So in this Jenkins file, I have defined my pipeline. All right. I've defined my pipeline. So here it is. The first stage is just the clone stage, right? The clone stage in the sense that I'm going to be integrating Jenkins with GitHub via SSH. So my Jenkins and GitHub are going to talk with each other via SSH. Right. So that's how the integration is going to happen. All right, via SSH. So that's why you have this section, right? So git URL, my repository, credentials. I'll be creating these credentials on Jenkins, right? So let's do that quickly. So I'll go to Jenkins, all right? I'll come to manage Jenkins, and I'll come to credentials, all right? Systems, global credentials, and add the credential. So the type of credential I'm adding is SSH username with private key. So right. So the ID is going to be Jenkins-GitHub. Right. So that's Jenkins-GitHub. So it could be anything, guys. The username is Jenkins. So it is Jenkins user that will be initiating this. Then I need to enter my private key directly. All right. I need to enter my private key directly. Okay, so I'll go to my Jenkins server, guys. So on this Jenkins server, I will generate. So this is my Jenkins server. All right, I will switch to the Jenkins user. I'll switch to the Jenkins user. So on the Jenkins home, right, you can see I'm on the Jenkins home. I'm going to generate what? My SSH keys. All right, I'm going to generate SSH keys. So let's do that quickly. All right, so let's do that quickly. So I'll say SSH key generate. The algorithm is RSA. Okay, the encryption byte is 4096. Then the user is Jenkins, right? So I hit enter. The file is okay. I'm not entering in passphrase. That's it. That's it. So I'm going to cut this file. I'm going to cut what? My private key. So this is my private key. So I'll copy that. So that is my, sorry guys, private key. So let me copy all of this. Copy. Come here and paste that. Paste. Paste. I have it. Good, guys. All right. Good. I'll now click on what? Create. Create. So my credential has been created. Now I need to go to GitHub, all right, and also fulfill this part. This part is we need to share both. I need to share my public key with GitHub. All right. So on this repo or on my accounts, click on my profile and go to settings, okay, and come to SSH and GPG and add a new SSH key, right? So this key will be Jenkins, Jenkins to GitHub to be deleted, right? So I'll delete it just to remind me that I'll delete it later. All right. Now let's now get out our private key. Sorry, our public key. So this is the public key, right? So these are public keys. I'll copy this public key. Copy it. Copy. Come over here and I'll paste that. All right. I'll click on what? Add SSH. So you need to verify because of two-factor authentication. Right. All right. So that key has been added, right? So you can see now that there is now an agreement. There's now a trust between my Jenkins server and my GitHub repository. All right. So let's continue, guys. All right. So this stage has been fulfilled. That's step 8 has been fulfilled. Now, step 11 is installing dependencies. Now, because I've used these libraries in my model, right? Scikit-learn, Kubeflow pipeline, NumPy, Pandas, Boto3, MLflow, Python, dateutil. All right. So because I've used these guys, all right. Sorry, this thing wasn't here. Let me remove this. It was when I was troubleshooting. I had to add this guy. Don't put it, guys. Good. All right. So this will install all dependencies that are needed to deploy the model. All right. The next is the actual model. So here I'll be running the model. That's run the script. I'll be running what? The model, which is this file, which you're going to see any moment from now. All right. We'll run the model. The model is going to what? Use all of these what's it called? Libraries, modules, right? Right? To create and deploy, all right, and get deployed, okay? And this model also is going to get connected to my MLflow, right? because it needs MLflow. So it has to connect to MLflow. From MLflow, right, it will create a pipeline on MLflow, and it also creates an experiment. So that experiment will run a task. The task will now what? Based on this data set, right? Based on the data set, it will now create a model. It will now create a model. After creating the model, it will now upload the model to my what? AWS S3, right? So that's what's going to happen at that stage, right? Everything, a lot of things is going to happen here, a lot, which I'm going to show you very soon. Okay. Now the next is what? Installing kubectl on all the worker nodes, because I've said that my agents should be any. So I need to make sure that kubectl is available on the worker nodes. All right. So this stage is installing what? Kubectl. Then finally, the last stage is the actual deployment into your what? Kubernetes cluster. So first, I'm making my kubeconfig file available to Jenkins, right? Once that is done, the next is now to use the kubectl to install these YAMLs. First is the secret, second is the service account, third is my inference service. All right. So this is the run flow of my pipeline, all right, of my Jenkins pipeline. So let's commit that, save this, and save that. Okay, great, guys. Now the next now is the input.json. All right, so this input.json file will come later. All right, to come later, I will show us. So this is the file that I'll use to run my inference service against, which is my model against. All right, to make the predictions. All right, I'll come back to this file later. Now let's talk about the inference service, the YAML. So this inference service, what's it doing? All right, is a special kind of Kubernetes object called inference service. All right, and this inference service is not a conventional service. It is only made available, right, when you install what? KServe in your cluster. Right. So this inference service comes with the KServe custom resource deployments, right? CRDs. Now the name is this is the name of the model, which happens to be the name of the model. The name of the service, the inference service, also doubles the name of the model. All right. Then the predictor, the service account is SA, which is being referenced from this service account, the YAML file. All right. The model formats, I'll be using MLflow. The protocol version is V2. Then this is the most important part. This is my storage URI. My storage URI on what? On S3. Now, this bucket, this thing you're seeing here is my bucket name, which we have here. Let me duplicate this. Right? So, like I said, to really understand this, you need to go and watch this first video, this first approach. Right? Watch the first approach. So let's go to S3. Watch my first approach. Right? Once you've watched the first approach, your understanding of the second approach, which is production, will be very clear. All right, so we have this bucket here, right? And in this bucket, there is a folder, rental prediction model, which we have in here. Now, within this folder, right, there are what? There are going to be supporting files, plus my model, my real model that comes with .pickle file, which is the artifact that we really need, right? So based on whatever that is here, KServe will deploy your model without you going through the hassle of creating Docker file, creating images, and deploying all of that into your Kubernetes cluster, right? So this is just a second route, all right, an easy route, not really an easy route, but it's just an alternative, all right, an alternative to using Docker, right, to deploy model into a Kubernetes cluster, right? Like I said, it was in this video I took my time to explain what KServe is actually doing, right? So that's why you need to watch this first video, right? Watch that first video. So this is not your file, all right? The inference service, the YAML. Now comes the main file. But before I come to the main file, let me go to secrets. So I'll be creating some secrets. Okay, I'll be creating, it's not some secret, just the secret. And this secret is referenced in the service.yaml, sorry, the service account, which is referenced here. All right, let's go back to secret.yaml. So in secret.yaml, all right, just the normal way of creating secrets. Now, the idea of this is so that I need to protect my what? My S3 buckets. All right, I need to protect my S3 bucket. I don't need to expose my model. All right, it's just for security concerns. Right, that's why we need the secret. And this secret, for this secret to get authenticated, all right, I'm I'm wrapping my AWS access key and secret key, right, as a secret in the secret. And this secret will be used on this service account. All right, will be used by the service account. Okay, now, so that's it, that's secret. So I will be editing this value here. So I'll put the new secrets that I have here. So copy that and paste, and copy that and paste. So that's my new secret. So let's save it. Let's save it. Commit and commit. So that was our secrets. Then the next is service account, which you've already seen. All right, you've already seen. Then finally is the model of PY. So the model of PY, let's take our time to explain the model of PY. All right. So yeah, I also have a video I've done on MLflow. Right. So you need to also watch that video. All right. You need to watch that video as well. Let's look at it. MLflow. MLflow. Do I have it? Yes. So guys, you need to go and watch this video, which I did sometime. Right. So this will give you a better understanding of what MLflow is doing in this my context. All right, this is my context. So I'll be using MLflow libraries. All right, from import MLflow.scikit-learn, model signature, inference signature. All right, and this you can see we have all of these: the pandas, the numpy, the login, boto tree, because I will need to interact with what? With AWS S3 from Python. To do that, there's a library called boto3. So I need to download the model, my data set, use the data set to train the model. After training the model, all right, make predictions, then finally what? Upload your pickle file as an artifact back to what? AWS S3. All right. So from scikit-learn, this is where I'm bringing in the libraries for the model training. I'm using this algorithm, linear regression. I need to create some metrics. All right. So scikit-learn metrics. So I'm importing this method. I'm importing the mean squared error as well as root square for scoring. Sorry. Root mean square scoring. Okay. Now, this is where I'm performing AWS S3 upload details. My bucket name is this, all right? And my S3 prefix is this, okay? Great. So my local data path is going to be my data / rental, which is on the agents, all right? Then local model paths will be this. Then the data on my S3 path is this, which we have here already. /data / my data sets, rental 1000.csv. That is my data set. All right, great. You can always request for this code as well as data sets. I'll share it. I'll share it with you. Right. Then the model, right, will get deployed back to my to my S3. Okay. So this is where I am calling the environment variables. All right. I'm using the environment variables. Okay. So I'm going to create these environment variables in Jenkins as well. Right. So let's pause there and do that quickly. Let me not do it now. Let's look at all the errors that we are going to encounter. It's very important, right? So I don't want to finish up everything so that and you don't see the errors. Not that so that when you now start practicing, right? You start seeing errors that you didn't see in my video, right? So I want you to see those errors, experience those errors, so that you will learn very well, very fast, right? So this area is doing nothing. It's just to confirm if your environment variables are properly set, right? I'm logging the login function from login library from Python. Okay, then finally this my Boto client, right? S3 client. Okay, all right. So I'm initializing the client, and this is the actual upload, all right? Upload function, right? Now, because I will need a lot of files. KServe, your model will need supporting files. So by that I mean, normally when we deploy our model as artifact to AWS S3, we usually deploy only the artifact itself, which is the model of PQ. That's this file, right? The model of the PQ file, the PQ file. However, in this context, if I were to deploy only the .pq file, it will defeat the purpose of using KServe to serve your model, in the sense that the model needs other supporting files like, or I'll say KServe, right? Using KServe to deploy an inference service, right, requires not only the model, it requires requirement.txt file, it requires the model itself, it requires the artifact itself, it requires other files, which we are going to see very, very soon, right? Within what? This folder. Okay, within this folder. So that's why we need to what? We need to upload the entire directory. And when you upload the entire directory, you get to see other files that are needed in that directory, right? So this section is doing all of that, right? Uploading from the local back to what? S3. So these are just using the OS Python library just to create directory if they don't exist, right? Create a folder if it doesn't exist. So this is a way, right? OS doesn't make directory. It's a method, and that method I'm going to pass the path. OS will pass the directory name, which is this name, all right? Then exit.ok, true. You should create it, all right? That's what that parameter is doing there. Exit underscore okay, yes, true. After creating this directory, now download the dataset from S3. So this part is downloading the dataset, which we have to your what? To your local path. To your local path, which was created in here. All right. Now, once it has been created, now you need to load the dataset using what? Your pandas data frame, right? The data frame equals pd.read.csv because it's a CSV file from where? From a local path. Okay. Based on that, it uses data set, right? So now what? Start performing the data set has 3 columns. It has rooms, area, and price, right? Based on the rooms and area, right? You want your machine learning model to make a prediction, right? If your room is 2, you're looking for a room that has 2 rooms. You're looking for a house, an apartment that has 2 rooms, and the area within a square foot area specified, right? What should be the price, right? So based on the rooms and area, make a prediction of what the price could be, right? So that's what this data set comes with, right? Great. Now, what this command is doing is converting, all right, this into NumPy arrays, all right? That's why I have dot values. Okay, great. Pandas array, sorry, right? So this section is now performing the training and splitting, right? It's splitting what? The data set into 2 sections, the training data set as well as what? The testing data sets. Yeah, we are using the linear regression algorithm, okay? and we are using that to create the model, and we are making a prediction, right? Great. And now we are now setting up or evaluating our metrics. All right. So this is the section that does the metrics. So the metrics, right? So we need to measure the root mean square as well as the root square score of the model, right? So that section is doing that. Now comes this section. So in our model, we are using what MLflow API reference, right? Because we need to get connected to what? To MLflow. Look at this now. Jenkins will do all of this, right? So you connect to MLflow. So MLflow will create a pipeline on MLflow, an experiment that will eventually perform most of these tasks, right? So let's go back there, right? So now we need to create a server, right? So what that means, I will install MLflow on my Jenkins machine, right? Jenkins will use that to what? Connect to your MLflow endpoints. From there to create an experiment. The experiment name is rental prediction experiments. And based on that, it will now create a what? A run, right? If there are any other runs with that name, it will delete it, right? And recreate it. Okay. So signature, all right. Then this is the login section for the metrics, right? The metrics, and remove existing directory, blah 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 blah, local model path this, and finally you upload the entire directory that has all the files back to your what? AWS what? S3. All right. So this is all, guys. This is all that these model will be performing. So this will be the content of the directory, right? I have the model, I have the artifact, I have the registered model, I have my signature. All right. All of that will be uploaded into a directory to your what? To your AWS S3, right? So these are the things you need, guys. So that's what is in our what? Model, the what? PY. Then what are we missing? I think that's all, guys. That's all. Then finally, this will come later. I will explain this input.json later. I think that's all. So now let's start playing around. So, okay. So the first thing first, I'll now go to Jenkins to create a pipeline. So look at this now. All right. I'll go to Jenkins to create a pipeline. However, we need to install KServe. All right. We need to what? Install KServe, because we're going to have a lot of errors, because this KServe is going to use this secret.yaml file to deploy what? The inference service. All right. First, we need to install what? KServe. And to do that, let's go to KServe kubeflow documentation. So kubeflow.org. So kubeflow.org, I'll click on this down arrow and I'll get the components, KServe, all right? So this is KServe. So click on get started, all right? Now there's quick start and they're deploying your first inference, all right? We'll not be doing this because we did that already on this video, right? On that video. So now first thing first, I also need to install Helm. Yes, we need to install Helm on this our working machine. Install Helm, all right? All right, so let's look at that. So this is the link to install Helm. All right, click open a new tab, right? So quickly let's go and install Helm. I'll copy all of this. Whoa. Copy, come to your terminal. This is your control machine, all right? So clear the screen, paste that home, and you're good. So this is going to download Helm. Done. All right, we have it. Okay, the next is change, make it executable. All right, that home is now executable. Then finally, you can run this. Okay. There we go. There we have it. And there we go. So hem has been installed. All right. I'm still recording this. Great. So hem has been installed. Right. The next we need to do now is we need to go ahead to install what? KServe. So this is the link that installs KServe. So the version of KServe you're installing is version 0.15. All right. 0.15. So copy all of this, copy and come over here and hit enter. Bam. So let's first to install the CRODs, all right? Okay, custom resource definitions, and yeah, you install every other supporting services that are needed, right, to implement uh, inference service within Kubernetes using what? KServe, right? So while that is ongoing, let's go back to our diagram, right? So we're installing this guy now, okay? We're installing KServe, all right? So now let's now go and create a pipeline on where? On Jenkins. So I come over to Jenkins and I'll go to dashboard, new item, and let me call it KServe prod. KServe prod, there's a pipeline, and okay. All right, so I will scroll to the bottom, and my pipeline definition is a script from my source control, which is what? Git, right? So I'm using Git. So let's go and pick the repository. So I'll come to my repo. This is my repo. There we go. KServe, that's my repository, guys. So I'll come over here and I'll select SSH and bam. Okay. So come here and paste it there. Paste. All right, great. So remember, we created a credential called Jenkins. All right. So I'll give that. Now I'm having this error. So Jenkins is trying to run a Git command, which we don't have. So on my Jenkins server, there's no Git, right? So this is what I'll do. I'll install Git. I'll say what? Yum install Git, all right? So there's no yum install. Oh, that's Jenkins. Sorry, it's not the sudo user. So exit sudo yum install git -y. All right. So I'm installing Git. Okay. So our error should change any moment. Now our error has changed. All right. Now it's now looking for the credential. Right. So this is the credential actually. Right. So let me just save it. And there's one other settings that we need to change. I'll come to dashboard. I'll go to manage Jenkins. Right. And I'll come to this security. I'll go to security. Security, yeah. Then I'll scroll to the bottom, right? There's an SSH section. It says that Git host key verification configuration. I don't want to verify my host key, right? I can say accept first connection. I'll say save, all right? Then I'll go back to my pipeline, come back to my dashboard, open this pipeline, all right? Go to configure. We should have that sorted. So I think this is now sorted. So none, yeah, none, and this is now sorted. All right, great. Now the branch I'm going to build from is master branch from my GitHub. You can see the branch is master branch, right? Master branch. Then that's it, guys. That's it. That's it. So we've integrated what? Jenkins with our GitHub. So you can see, so Jenkins will be asking for the code while GitHub will be giving the code, right? So that's the flow, request and response. All right, great. So let's check our KServe if it is fully installed. KServe, let's check. What is this? KServe. So what did it say? It says well, successfully install what? KServe. Let's check, right? So we need to check for the custom resource definitions. I'll say kubectl get CRODs, right? Get CRODs. Now, when checking CROD, you need to check out for a particular CRD, which is inference service.7.kserve.io. If this CRD is not available, then you need to uninstall kubectl. You need to uninstall KServe and reinstall it all over, right? And I did that on this first video. So guys, you have a lot to pick up from this video. You have a lot to pick up from this video, right? So you need to go back, you need to watch this video thoroughly, right? Because you have a lot to pick up from that video, right? Because there were times I installed KServe and this service was not coming. So if this service is not coming, there's no way you can what? There's no way you can install your inference service, because your inference service uses that as a what? As an API. Does that mean that that API is not available? All right, great. So we've installed our inference service, and the inference service comes with Istio as well. There's Istio there. All of these was explained in this video. Please, guys, please make sure to watch this video. It was explained in that video. All right, great. So what do we now? What are we left with? We install this, right? I think we are good. Let's now start having some nice errors, right? Let's start having some errors now. So I'll now go and what? Deploy. So let me create an automated a webhook. Okay, I need to set up a webhook between Jenkins and Github. So I don't need to be manually clicking build now, right? I don't want to be clicking build now. So you can see, I click on build now, right? Definitely it will build, but we're gonna have we'll be doing it manually, right? We'll be doing it manually. Okay, so which I don't want to be doing it manually. So let's check what it's actually doing. It has failed. Let's check. Okay, let's check. Was our GitHub integration successful? Yes. So GitHub was successful, right? So let's check the first stage. Let's look at our stages. Come here and stages. So this first stage was successful, which is checkout stage. Clone repository, right? Clone repository was the stage that we integrated our Jenkins with GitHub via what? SSH, right? So what failed is installing the dependencies. So let's go here again. Let's check dependencies. Let's check the console. I need the console, guys. Come here. Console. It says that PIP is not found, right? Now, is it at is where is it now? Is it's at this stage? Jenkins file. Let's look at the Jenkins file. Jenkins file. It's at this stage. It's trying to install the dependencies. It says PIP is not found. So I'll come to my Jenkins server, all right, and install PIP, right? So I'll say what? Sudo yum install Python 3 PIP. I think that's how it comes. Yeah. So this installs PIP, right? So once that has been fulfilled, let's go and run the pipeline, right? But we are still running this thing manually, right? So this is what I will do. I'll go and create a webhook, right? Come to my GitHub. Under my repository settings, click on settings, all right? And go to webhooks, okay? And edit this webhook. This is what we have currently. Sorry, before. So I'll remove all of these and I'll now say GitHub -webhook. All right, so that's all we need. So the content type is application JSON. That's good. Update webhook. All right. So click on webhook. Should get some ping pong. Why am I having this? Why is it not responding? Is that one? Okay. Update. Come back to your webhook. All right. So let me delete this webhook. Delete. Add a new webhook. GitHub dash web. All right. So add. All right. So we'll come back to the webhook. So now let's redeploy this guy, build one more time, right? Now that we've installed what? PIP, right? Let's see the next error. Let's look at the next error. So you can see now it has gone past that stage now, right? So it's using this PIP to install this model, these Python models, right? So it's installing them. They're getting installed now. So let's just wait patiently. Let's wait patiently, guys. All right, so where are we having this challenge? But these are warnings. Okay. The script tablet is installed in this, which is not on path. That's okay. Those are warnings. All right. Now it's now on the next stage. It's trying to run this command, Python 3 model of py, which is at this level. It has gone past these dependencies. It's now at this place now. Let's look at the errors that we are having. The first error says, you can see the access key now. So it says your access key or security is not properly set. So this is the cliche. All right, let's go. Let's come back to this is in our model of py. All right, we used the login what's it called, the login model, right, to capture that behavior. Look at it here. If access key and this secret key, login info, access and secret key retrieved successfully, right? The value, yeah. Else, AWS access key or secret key not set properly. So that's why we are getting this output, all right, from the OS model, right? Great. So I'm going to create my access key and secret key as an environment variable on Jenkins. So what I'll do now is I'll pick come to your model.py, right? So copy these guys. I need those names. Copy. So I'll go towards my dashboard. Sorry, let me open two of these duplicates, right? Dashboard, manage Jenkins, and I'll come to what? System configuration. So under system configuration, I'll look for environment variables, global environment variables, and I'll add environment variable. So I'm adding a key value pair. That's a key. Add another one, and this should be right. So we're good. So my access key ID. My access key ID is this. My access key ID is this, right? Then access key ID is that. My secret key is that. Is this. We are good, guys, right? This way, Jenkins will read the environment variables. The environment variables will be available to what? To Jenkins. So let's save and apply. So good, guys. Now let's rerun the pipeline. See what happens. So this is the pipeline, right? So build again. So I have build ID number 3. So let's be watching, right? So this is the stage, right? This was the stage that failed. Now it has gone past that stage because it's now seeing what? The environment variables. Now we are now having a different error. Now the next error is, let's watch this. The next error now is trying to create using the MLflow API reference. Look at now, it's trying to create an experiment, but there's no MLflow server. So we need to set up an MLflow server, connect to this environment, to this endpoint, right? So that everything will flow. Let's check the error. So this is the error you'll be getting, saying that failed to establish a connection error. All right. So now let's go to MLflow documentation. All right. On how to do what? Install MLflow. Right. Let's do that quickly. So come here. MLflow.org. So this is the official website of MLflow. So I'll click on what? Get started. Right. So guys, if you've not watched our video on MLflow, please go and watch that video. Watch that video. So getting started, where's the quick start? Quick start. So under this quick start, right, I'm going to install MLflow. I'll be using what? PIP to install what? MLflow. Let's copy that command. Copy, come to my Jenkins server. All right. Is it on my Jenkins server or where? All right. So it's going to be, is it Jenkins? All right. It's going to be on Jenkins. All right. Let's do that quickly. Let's see. So PIP install MLflow. So I'm installing that on my Jenkins server. All right. So immediately that is installed, right? Then we need to start the tracking server. So here's the command to start the tracking server, right? So I'll copy this command. What's it saying? It's saying that cannot uninstall request. So what I will do is I'm going to query that file, that model. It's a file, right? I'll query for I'll query all the installed packages, RPM packages on this server, and I'll query for requests. Let me see that file. So I'm going to uninstall this file so that this installation can go through, right? So I'll say what? Yum remove Python 3 requests, right? From this server, right? Yes, I'm removing that. Now let's rerun the PIP install one more time. Install this, and everything should be successful, guys. All right. It's going to install the version that is very compatible with it. All right. Great. So great, successful. All right. Let's see. Going. All right, we are fine. Okay. We are fine. Okay, these are just AWS CLI dependencies. We are fine. Okay. Let's continue, guys. Now that we've installed MLflow, we need to start the server, right? But let me run it on port 5050 because as you can see in here, it is running on what? Port 5050, right? So I'll hit that and I'll say 5050. Now, the moment I do this, it automatically what? Starts our tracking server, which is our MLflow server, right? However, it has taken ownership of my terminal, right? So for me to have access to this Jenkins server, I need to run this process in the background. So what I will do, I'll terminate it. So I'll now say no hang up, right? And I will paste that. It will be 5050 and it should run in the background ampersand, right? So this no hang up creates a file called no hang up dots output. So it shows us what is already running. So as you can see, our MLflow is up and running. All right. So let's go back to run the pipeline. Come back here now. Let's retrigger the pipeline. Right. Build now. So build this pipeline. So you can see how this session is making sense, right? Because you can see now, yes, it has gone past that level now. So render prediction does not exist. So creating a new one. So creating what's it called? Creating an experiment. An experiment has been created, and these files has also been created, and these files have been uploaded to my X3 from where? From my MLflow. So those files have been created, have been created by MLflow, and they're now being pushed into what? AWS S3. Let's go to S3 and check. Come over S3, and if I refresh this page now, we should have those files already. You can see these files. These are the files: conda.yaml, ML model, model.pickle, Python environment.yaml, and requirements.txt. All right. So these are the supporting files that are needed by KServe to create a what? An inference, right? To create an inference within our cluster. Let's check the errors that we are getting. So we're having few other errors. All right. So yeah. So this is coming because of this date util something. All right. You remember I removed date util somewhere. So it's complaining. So let's see how we can reduce the version. So let's go back to that error on Jenkins. Look at this error on Jenkins. It says that AWS CLI requires Python date util less than or equal to what? 2.9 or greater than or equal to 2.1. But you have Python date util 2.9 post, which is incompatible. Right? Is incompatible. Which is incompatible. All right, so let's install. I didn't install AWS CLI here. That's why I'm having this error. All right, so let me install AWS CLI on my Jenkins server. Guys, we didn't install. Where we installed AWS CLI was on our control machine. All right, now AWS CLI, the version of AWS CLI that comes with this AWS operating system is not compatible. It's interfering with Python models, Python libraries. It's interfering. So that's why we're having this error, right? So I want to go to AWS official website to install the official AWS CLI. So that AWS CLI is independent of any Python library, right? So this is what I will do. I'll say what? AWS CLI install, or I'll say install AWS CLI. All right, open the first link. So this should do the magic for us, Linux, right? This should do the magic. Copy all of this, right? Come over here, your Jenkins server, right? Then let me exit over here. Great. So let's paste that guy, paste everything. Let's do that. Pick one. All right, so now that that's been installed, let's exit our terminal, right? And come back. Let's come back. Now that we've installed the appropriate AWS CLI that is going to boycott these errors, right? Where's that error again? It's going to boycott those dates util wherever that we are having, all right? So it's a serious error, guys. So AWS CLI from the official website will rectify that. Why? Because the AWS CLI from the official website does not interfere with Python libraries, right? But the one we have on the machine is interfering with Python libraries, can see. So these are serious headache, which you've boycotted. So let's check our pipeline one more time. So we come over here and we build one more time. That's let's check. All right. So model of PY. Okay. Let's check. Okay. All right. Let's check. Now you can see we're able to what? Use what? AWS command. So we're no longer having what? Those errors. Now the what's it called? The kubeconfig was downloaded, which is this stage. Where's that stage? Which is this stage. This was installed, which is this stage, right? And finally, the last stage, 35. All of these were installed. Let's check it out. You can see. So our pipeline now is now what? Successful. and an inference service has been created. So if I come to my cluster, I go to my control machine, I come here, I say kubectl get ISVC. So ISVC is an inference service. That's the short form. If I hit enter, I can see that this guy has been created. However, it is in an unknown state. It is in an unknown state. We are going to check why it is in an unknown state. So let's describe it. Let's say kubectl describe inference service. Then the name of the inference service. Name of the inference service is this. Let's check. Let's check why it's in the pending states. Is there any reason? Predictor ingress not created. Not created. Ingress unknown. Why? So let's check one more time. Let's check the service again. Sometimes take some time to be ready. Take some time to be ready. Okay, now if you're having such an error, it's not really an error, but it's related to permission. So this is what we'll do. We'll go back to AWS. All right. We'll go back to AWS. All right. Now there's a rule. Let's look at our rule. Let's look at our rule. Duplicate this page. Let me close some of these. Guys, take note of those videos. Right? Come to IAM. Go to roles. The roles I've used on the worker node. Let's check the worker node. Instances. All right. Let me check the worker nodes. But let me go to my cluster. I'll see it on the cluster. Let's open your worker, your node group. In your node group, you should see your IAM role that you attached to. So the IAM role I attach is delete worker role. So this role does not have access to AWS S3. Let's look at that role. Delete worker role. So this role, let's look at the permissions. It doesn't have AWS S3 access. So that's why we are not getting this endpoint is not getting ready, right? So I need to grant that role full access. So what I'm doing now is I'm granting the worker nodes access to AWS S3, right? So I'll add a permission, add policy. So I'll say S3 full access, S3 full access, S3 full access, all right? Then add permission, added, right? So now that permission is added, it will take some time to be available. Let's just wait. Let's just wait. So if it's taking much time, let's rerun the pipeline. Come back here. All right. Rerun the pipeline. Do it one more time. It's taking some time. So let's build the pipeline one more time. Let's build. Okay, now let's check if that doesn't come yet. Doesn't come. Bam. Doesn't come. Doesn't come. Mm. Mm. Let's describe it one more time. Why? What could be happening? Mm. So the error is not glaring. Error is hiding. Error is hiding. So what could be this? Let's go through our work one more time. What could be the culprit? We are good in all fronts. We are good. Let's check AWS side. We are good in all fronts. We are good. Permissions. We are good. Okay, let me make these buckets publicly available. Let me try something. Make this publicly available. All right. I understand. Save. Okay. So let's check. Let's rerun the pipeline one more time. I've made the buckets publicly available. Let's rerun that. And what else are we missing? Credentials are on point. Credentials are on point. Jenkins server. From my Jenkins, I can query from Jenkins. I can query S3, AWS S3 list. Okay, sudo switch to Jenkins user. AWS S3 list. Okay. Okay, guys. So from Jenkins, we can't talk to AWS S3. All right. We can't talk to AWS S3. I think that could be the cause of our challenge. So Jenkins does not have the permission to S3 as well. All right. So what I will do is let me authenticate AWS configure. All right. Configure. Guys, watch AWS configure our credentials. Copy this. All right. So the Jenkins as a user must have access to S3. Okay. So come here, paste that EU West 1, then JSON, right? So if I run AWS STS get caller identity, I should have that. Now AWS S3 list buckets, we can list the bucket, right? And also list objects in our bucket. Our bucket is test dash MLOps dash PKT, right? Can list the content, all right? We can also list the content of our rental prediction folder, prediction dash model folder. So list the item. So we are good. Let's check now. Let's check. Come back here. Let's check now that Jenkins has access. So we're now seeing false. Now that's moved from unknown to false. Why is it doing that? Let's now describe it now. Let's see the actual error. Great. So now the actual error is coming. Let's see what is the actual error. What is it saying? What was the actual error? It says when calling a list object operation, the bucket you are attempting. What was this? Prediction model. Okay, let's run the pipeline one more time. One more time, guys. One more time. Why am I getting that? Control. Which error is this? Finally, direct when calling a list objects operation. The bucket you are attempting to access must be addressed using the specified endpoint. They send all future requests to this endpoint. All right, so let's check. Let's check this file one more time. Let's check our inference service. Inference service. Prediction model. That's correct. That's okay. All right, so let's check now. Let's check. Let's check. Get this guy. Still showing false. Describe. Model load failed. Model load failed. Model load failed. Is our MLflow still running? PS-AUX grep ML. Yeah, it's still running now. Port 5050. Still running. What are we missing? All right, let me do one more thing. Um, I've given full access. Let's check the objects in this bucket. Come here. But this shouldn't be the case. Refresh. Full access. Full access. Okay, 1 second, please. Wasn't this? Okay. All right, so quick one, guys. Let's see how ChatGPT can be of help. Wait, what was this? EST. Are we making mistakes somewhere? Bucket name. It's cutting the bucket name. EST MLOps BKT. Let's check. Has something changed somewhere? This is test. Let's come to our model.py. Model.py. The bucket is this. Let me check for buckets. It's only one. Let's check. Let's check this. It's correct. Jenkins file. So where is it picking this from? All right, so let's do something. Let's give this problem to ChatGPT. Let's give it this problem and see how it handles it. ChatGPT, paste. Let's see how it handles it. Let's see. From an Amazon S3 bucket, but the requested failed because due to an S3 endpoint misconfiguration. You are using a bucket in a non-default AWS region, but didn't specify the correct regional endpoint. You are trying to access a bucket in EU West 1 using a generic S3 endpoint like this. Okay. 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 Convert the endpoints explicitly in the URI. So this in the URI is S3. This is correct. All right. You may need to switch to using HTTPS style, which is this. Adjust your Ubuntu 3 configuration like this. EU West 1. I didn't get this error now. Okay, let's all right, my lovely viewers. All right, guys. So after multiple back and forth, all right, so what I did that finally resolve the issue is this is my bucket, right? So I was using this old objects for obvious reasons. It worked before, all right, but for obvious reasons, the second time I'm using it, I was having that error of let's describe this. So this was the error I was encountering, right? Okay, so I've done so much back and forth. Okay, so it's an issue with Boto 3. It's an issue with Boto 3. So what I later did was in my model.py, I had to recreate the directory. So where is the directory? I had to recreate this directory instead of the old one, which was rental prediction model. I removed model and said rental prediction. And that's what you have here. Rental was prediction. And immediately we got our endpoint. So this is our endpoint, guys. All right. So this is our endpoint. So with this endpoint now, I will now perform my prediction. All right. So now let's go back to Kubeflow documentation. All right. So the next page will be first inference service. Okay. Though we already have our inference service, which is running, and we have our endpoint, which is like this. Our output is this. So when we run this, all right, we're getting something very similar. Okay, great. Then the next step is to check for your Istio service. So let's check our Istio service. Copy this, come here, and clear my screen. So yeah, so that's our Istio service, right? Istio ingress gateway. Okay. Then the next step is using this load balancer. All right. Let's export the host name and the host port. All right. So I'll copy the host name, copy, come to my terminal. I'll paste that. So in place of IP address, I'm going to give, in place of IP address, I'll give host name, host name. So if I hit enter, I have it. So if I now echo the content of ingress underscore host, I should get the host name, which is this value here. All right. Now let's do for the port. The next one is for the port. So the port, I don't need to do anything on the port. It's just straightforward. Oh, sorry. This is for the ports. Okay. All right. So we've exported both the host name, the ingress host, and the ingress port. All right. Now, the next will be, we'll come to from ingress gateway with host header. All right. So you can see we have service host name. So the service host name, what we'll be doing here solely is kubectl get inference, the inference name in the namespace. All right. So let me copy that, copy. Let's come here to edit it. So kubectl gets inference service. All right. So our inference service, let's go there. So I'll paste that and let's do some editing. So I'll come in here. So my inference service runs in my default namespace, and my inference service is rental dash prediction dash isvc. All right. So I'm passing that to the variable service host name. So if I hit enter, I should have it. Now let's echo what's inside of what service underscore host name. So we have the complete URL of my what inference what service. Okay. Then the last part now is to query for your prediction. All right. So using call, the service host name, followed by the content type, the header, and the ingress host and the ingress port slash the path to your what to your model dash d, then your what your input variable. This is where this file comes handy. So we will be using this file. We are going to be passing our input parameters, right? Parameters that will be used in performing prediction. To check the prediction when the number of rooms and the square area changes at every time. What will be the price of such feature? Okay. So I'll just copy this file, copy the content, and come to my terminal, right? I'll create a file called input.json, right? And I'll paste the content inside. Oh, sorry. Let me copy it again. Oh, sorry. Copy. We have it. All right. So let's escape, save, and quit. Now I'll go and copy my um I'll go and copy was it I'll go and copy I'll copy um first. Yeah, I'll copy this last part. Where is it? All right, which is this? All right. So I'll copy this, right? Copy, copy, and come to your terminal. So we're going to do some changes, right? So first, my input is the file that has my test values, all right? So it's in this current directory, and the name is that input dot that. Now my model, my model is v2. The model is version v2. Then the model slash the name of the model. So the name of the model is rental prediction ISVC. Where is it? Rental dash prediction dash ISVC. All right, slash inference, because we want to perform an inference on that endpoint, right? So if everything is fine, we should be good. So let me hit enter and see what happens next. Enter. Good. Great, guys. So as you can see, our prediction was done successfully based on the input values. Now let's look at this now. Connection to the host. Model name. This is the model name. The ID is this. And the parameter, content type. All right. The output, name, blah, 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 blah. Now, based on that, this is the prediction. So this is the data, and this is the prediction for when the number of rooms is 2 and the square feet area is something around 600. Now, the number of rooms is 2 and the number of the square feet area is 600. So if I come here now and modify this value, let's say the square feet area is 1600 and the number of rooms is 3, right? What would be the predicted price? What would be the predicted price? So I'm going to rerun the model on this endpoint. So if I hit enter, right, let's hit enter and see. So let's see. So you can see the value has increased to 29,998. Before, the value was 1120. Why? Because the number of rooms was 2 and the square foot area was what, 600. But this time around, we've increased the number of rooms to 3 and the square foot area to be what, 1600. So this way, guys, we have been able to use our own model, right? The model that we created, all right, and published to AWS S3, all right, to perform what, an inference, right? To perform an inference, to make predictions, right? So this is it, guys. This is it. So this is a typical Kubeflow staff, KServe, in what, in production, guys. If it's been a whole lot because of the error that we ran into, and we've been trying to make sure that the error is fixed, and thank you for your patience, and it was fixed. And what we did to fix it was just by changing the object name, all right, from what we had initially to just this name, rental prediction. I hope this session has been very informative, and I hope to see you guys in our next episode. Thank you. Thank you, guys, and see you in our next episode. Peace out. Right. So you can see predictions are going fully well and everything is smooth as expected. Thank you and see you in our next episode. Peace out.